Hey guys, Physics in the Flesh is back with another circular motion problem. Law of Universal Gravitation, Problem 1. At the surface of a certain planet, the gravitational acceleration g has a magnitude of 11.0 meters per second squared. A 22.0 kilogram brass ball is transported to this planet. A. What is the mass of the brass ball on the Earth and on the planet? And B. What is the weight of the brass ball on the Earth and on the planet? So the idea behind this problem is simply to shine a light on the distinction between mass and weight, the two things that I've underlined here. Okay, so for part A, what is the mass of this brass ball on Earth? Well, we're told the mass of the brass ball on the question. It's 22 kilograms. Okay, so the mass on Earth is 22 kilograms. Now, you might think on the one hand that might change when you go to a different planet because a lot of people say, hey, if you were to be on the moon, you'd feel a lot lighter. And if you were to be on the planet Jupiter, you'd feel a lot heavier. But that's not referring to your mass. That's referring to the force of gravity on you. Okay? Mass refers to the amount of matter contained in an object. And when you go from one planet to another, the amount of matter you have doesn't change. So your mass is also constant. Therefore, whatever mass you have on the Earth is the same mass you're going to have on the planet, is the same mass you're going to have anywhere in the universe. Now, I want to make a clear distinction because these are AP Physics level problems. According to modern physics, the faster you go, the heavier you become, the more mass you get. So, of course, what we're saying here is this is accurate based on, standard speed objects that we're dealing with, not things that are traveling close to the speed of light. Okay, regardless, I think I got a little bit off topic there. Okay, B, what is the weight of the brass ball on the Earth and on the planet? Okay, so weight, by definition, whenever you hear the word weight, it is a vector. It is not that thing that you stand on the scale and it tells you your weight. Okay, that's a different context. Weight in physics means the force of gravity. What is the force of gravity acting on you? Okay, so let's do the planet first. The force of gravity on the planet is equal to your mass times the acceleration due to gravity on the planet. Okay, so your mass, of course, is constant. 22.0 kilograms, and the acceleration due to gravity on the planet is 11.0 meters per second squared. Multiply those two together. A kilogram meter per second squared is a newton, so you end up with 242 newtons. So this is the weight on the planet. So there's your first answer. Now we have to do the same thing. We have to find the weight on the Earth. Okay, so the force of gravity on Earth is the mass times the acceleration due to gravity on Earth. Okay, so you're not given that in the question, but it's assumed that you know it. Okay, so M, 22.0 kilograms, GE, 9.8 meters per second squared. Multiply those two numbers together, you're going to see it's going to come out to be less than this. You're going to get 215.6 newtons. Okay, so your weight on the Earth and your weight on the planet are a little bit different. So there you have it, guys. I'm going to end the video there. I hope you enjoyed it. Be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned for the Law of Universal Gravitation 2 coming up tomorrow in video 88.